Hello everyone, this is Singh 𝐒𝐿 and today I am back with another video where we will be discussing another architecture of Uber. So in the previous video, one of the previous videos, we discussed the Flipr architecture where we discussed how a config system is designed at Uber and how different systems leverage feature flags. So in that architecture discussion specifically, we mentioned that it's a pull based approach. So what is the meaning of pull based approach? It's just that uh, all the systems store the configurations and then they pull for those configurations that give me the key, like give me the value for this particular key, or like get me the entire configuration of this particular namespace, or all those things, right? So what you are doing is the client, whoever is responsible or whoever wants to consume those configurations, have to ask for those configurations via some API calls and then use it. uh, Today we are discussing one improvement over that architecture, which is based on push based architecture. Okay, so you might have not, so whenever we talk about push based architectures, right, you generally see these architectures in kind of like notification systems, okay, or like wherever you want to support or notifications or send updates from the server, such as real-time messaging, right, or the notifications. So these kind of scenarios, or you are building a news feed, right, so these kind of scenarios are often solved via following a push based approach by establishing some persistent connections. But this is not around that. The idea is that you deliver those so clients basically don't ask for the configurations, they just subscribe for the configurations, and then the distributor system, the configuration distributor system, is responsible to send those configurations to whoever is subscribed to those particular configurations. Okay, there is no persistent connection in picture, uh, just to let you know, but they work on the basis of that. If there is new an update or not, if there is any new update, then it is sent to the clients. Okay, so let's start our discussion, and the discussion is based on one of the engineering in Uber engineering blogs, which is how we unified configuration distribution across systems at Uber. So as we mentioned, how the distribution is unified. So earlier, there were like separate, like multiple clients who were pulling for those configurations, and now they have a single system who is responsible to store these configurations and then distribute it. Okay, so we are specifically talking about the distribution pipelines here. Okay, so first of all, like we will discuss different challenges. What are the challenges, what is the different terminology, what is the new architecture, and how the configurations are deployed. So let's get started through our notes which I created as per my understanding. Okay, so what are the things, what are the things that you need in a configuration system? Okay, so first is the configuration store, where you are storing those configurations. Very easy enough. Generator, generator is responsible for creating those configurations in the consumable form. Now when I say consumable form, it's just mean like maybe you are storing those configurations in the compressed format, okay, but you are delivering those configurations in a readable format, let's say a JSON format or XML format. So that's what we mean by generator basically. Distribution pipeline, as name suggests, it's responsible for distributing the configurations which are stored in the store, or like kept in the configuration store, to whoever the clients like which are basically interested in. Rollout mechanism, uh, it's very important that whenever you are doing any configuration, whenever you are doing any deployments, or whenever you are making any changes in code, you have a proper blast radius in mind. Okay, you should think around that your blast radius minimum whenever you are making any changes in your system, specifically production systems at Uber scale, right? So whenever you are making any changes, you want to ensure that the changes are rolled out gradually. Okay, which means that you are minimizing the blast radius. Minimizing a blast radius as in you are not impacting the 100% customers at a time. So, and that's how the feature flags are helpful, and the rollout mechanisms comes in picture, which is solved, or like which clients don't have to handle at their own. This distribution pipeline itself solves that purpose for them. So it has an incremental rollout strategy, and it can be defined by the clients, like it has to be distributed in the single zone or multiple zones at a place, how, what is the frequency and all those things. Okay, cool. Configuration client, configuration client is a client client library which is present on the service itself, like which is with the service which is consuming the configuration. So it is basically getting those configurations and then make the configurations available to the service to consume. So this is like the overall architecture, or what you say, the idea of what you need, basically the you can say the functional requirements, right? What you need in the system. Now, before coming with the architecture, before moving forward with the architecture of how things work right now, we should understand what are the issues. Okay, so it is kind of a part of our requirement gathering only, that we understand what are the issues currently so that we can address them. Okay, if you are able to identify whatever the issues are, so you can come up with the approach that these issues are solved in the new architecture, whichever architecture you are designing. Great. So what are the issues? First one is scalability. 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 Scalable, basically. Okay, so earlier distribution pipeline used pool-based approach, as we discussed at the start of the video, means every system pull data periodically. Great. But what happens is, since every system is consuming those configurations and there can be multiple duplicate configurations which our systems are pulling, so there are duplicate calls, and the network stack has lot of configuration or a lot of calls which are duplicated. So you can somehow, there is a possibility that you can reduce them. Great. Multiple distribution pipelines with maintenance overhead, because all the clients are pulling the configurations, all those clients are responsible for pulling of those configurations. There are multiple distribution pipelines which are created, and which means that you have to maintain those distribution pipelines. You are adding that operational overhead. Right? Resource consumption. Now again, since multiple clients are pulling for the configurations, these configurations are the calls are being made from the different hosts, or 150k hosts, and it increased again. It's again related to our first point, propagation latency guarantee. Now, since clients are pulling the configurations, there is no specific SLA which can be defined, that like this is the SLA, or like this is the guarantee I am providing to pull these configurations, or they are updating at this particular frequency. Okay. Incremental rollout support. So this is one of the thing we discussed in the rollout mechanism as well in the previous discussion, this here, that we have to ensure that we have proper rollout mechanism in place to deliver those configurations to the clients. Now, we mentioned that we had multiple distribution pipelines earlier, and not all distribution pipeline has that proper rollout mechanism in place. So and it's again a maintenance overhead, right? If you are managing the entire rollout strategy, different kind of rollout strategy in all the distribution pipelines, so how you can do it? How can you minimize the effort which you are doing? Just do it at one place, which is our configuration store, which we are discussing today, and then leverage it across the systems. Great. So these are the issues which we are facing. We already discussed what we need in a configuration system. Now, the architecture, UCDP pipeline. What does UCDP mean? UCDP mean Unified Configuration Distribution Platform. So it's responsible for configuration. It has the configuration and it is distributing those configurations to whoever client is subscribed for those particular configurations. Great. Now, before moving to the architecture, right, there are few terminology you should understand which are specific to this architecture. First one is the configuration property. Property is, as we discussed in the Flipr architecture, it's a key value pair. Okay. Your Yeah, it's a simple key value pair. Then you have a configuration namespace. Namespace, you can say a combination of multiple properties which are related. Now take an example, let's say these configurations are related to India. Okay, so this is one of my namespace, or these configurations are responsible for some particular service. Okay, these configurations are used by some particular service. So accordingly, as per that, a namespace can be defined. It's just a combination of properties which can be pulled together. Okay, so whenever you ask for a configuration, you define that, yeah, this configuration is present in this namespace, or you can pull out the entire namespace and then check out the details of all the configurations which are present in that namespace. One entity higher. So you have a property in like multi combination of properties, you have namespace, and then combination of namespace you have domain. So all the related namespaces are defined in a single domain. So let's say Uber has multiple functionalities, right? So let's say Uber Eats. So Uber Eats has delivery mechanism. So delivery is one of the domain, and in this particular domain there are multiple configurations which are kept, which are used by the systems which are responsible for delivery of things, right? Okay, so we are clear with the terminology now. Another thing which we are discussing here is we are combining distribution pipelines. We are providing an API to distribute the configuration to all hosts within Uber with specific rollout pace. We will discuss all these points in the architecture below. Client library to read the configuration and subscribe to updates, and then agent running on all the Uber service, which helpful in making configuration available to workloads which are running on the servers. Okay, so we will understand this with the architecture which is below. All these points which are mentioned here, or which I just read it now. So if I talk about the overall area, like how the services are deployed, before we get into this configuration specifically. So assume that you have a region, and then you can also compare it with the AWS cloud terminology. So you have a AWS region. In the AWS region, then you can have multiple availability zones. Okay, and in those zones you have different hosts deployed. Okay, so this is what you have a global, and then in global you have multiple zones. You can, in zone here, I believe refers to availability zone, but it could also be a region, right? So global can be combination of multiple regions, or it's a single region in which you have multiple zones, and then in zones you have multiple hosts on which service workloads are deployed. Great. I hope you understand what the architecture looks like of the systems, like how the services are deployed. So like whatever service you have, they are basically deployed on the host, on the VMs, depending on type of workload. It could be stateless or stateful, but they are in the end deployed on the host, whatever the kind of your workload is. Great. Now you have producers, which they have the API to create the configurations or update the configurations. They do that. UCDP is a system which is then responsible to send those update to the customers. So these consumers basically subscribes to particular configurations, and then whenever there is new update, they send that update to the consumers. Understanding it more further, the same architecture which is here, just little bit like more blocks. Okay, so this we already discussed. Global is your global control plane of system where the deployer is present. So again, whatever we discussed here, right, this is the producer. Okay, so producer interacts with the UCDP system, that these are the configurations, and then according to a deployment, according to a rollout strategy, I will figure out that for this particular configuration, this is the rollout strategy, and as per this rollout strategy, this deployer is responsible to store these configurations and then send those updates to the distributor system. Okay, this distributor system store those configurations in itself, which is a gold state store. Okay, uh, it then keep on checking, like whenever there is a new update, if there is any new update, it send that to a UCDP host agent. Okay, this host agent runs on every host, so every single host, so there are multiple hosts on a single zone. Every host runs a host agent which pulls these configurations. Okay, once these configurations are here, they are updated to a local database, disk storage. This UCDP client is specific to a service. Okay, so it's a library which runs alongside a service. Okay, so you can assume it a sidecar container. This UCDP host agent, you can assume it as a separate virtual machine which is running alongside the different services. So this is one of the service. There can be multiple services on this single host. Great, getting the idea? Okay, so this UCDP client subscribe the UCDP host here. Okay, and then whenever there are new updates based on a notification event, like whenever there are any changes are made to the file system, so depending on this 𝐼notify event, uh, depending on the 𝐼notify event, this one specifically, if there is any update, it is consumed by the service and then it is utilized in the service itself. So these are the steps which we discussed, right, with like this steps which I described right now, and it is discussed with the Flipr architecture which we discussed in our previous video, and Flipr was responsible for to store these configurations. So quickly summarizing whatever I said, they are written in the points. So producers such as Flipr use UCDP producer client API to deploy the configuration updates. Great. Producer is responsible for deploying the configurations. We have the configurations at UCDP system. Now we have to deploy these configurations to further hosts in the multiple zones, or like whichever zones we have. Great. So deployer upload the configuration and update the artifact store. Okay, great. Update global deploy state, responsible to identify that like how I am deploying these configurations. Zone update the zonal goal state. So it's just that at every level, okay, global, you have your system deployed at global level, this UCDP, right? Then it is responsible to spread out those configurations at zonal level. Now each zone has a separate goal state which maintains these configurations in place, that yeah, these are the clients which I am or like these are the clients which are interested in these configurations, and depending on like whoever is subscribed to. Okay, so this distributor knows which host this update has to send to, so it do not randomly sends the update to all the host, right? Not all services running on the host are watching or like interested in all the configurations, so the distributor figures out which host these updates needs to be sent to. Okay, so these are updates depending on that. Rollout strategy update is pushed. Great, this is done. Zone update the zonal goal state, this is great. All distributed instance listening to the updates. So as I mentioned, all the instances which are subscribed to, basically, okay, they receive those updates and then save the copy. Okay, distributors send a configuration patch to all the hosts with active subscribers. This we have to figure out, that whoever is interested in, to those only we will send a update. Distributors send a, this we discussed, host agent writes update to disk, and then once it is saved to the disk, it can be uh, retrieved by the service client, the client which is running here, which is UCDP client, right? So this is the overall architecture. If we quickly talk about the results, so this helped in reducing 25% network calls as compared to pool based approach. Okay, so as compared to our previous architecture which we discussed in the Flipr, there was 25% reduction. Reduction means we are reducing the number of resources, or like whatever updates or whatever calls you are making. So you are reducing the strain on the network infrastructure, plus since you are reducing the API calls, you also need lesser infrastructure to run those same or receive those same configuration updates. If we talk about scale, and it also helped in reducing the startup time, because the configurations can be because the configurations are directly available on the cache, and they don't have to be pulled out from the Flipr in the previous architecture, right? If we talk about scale, we have 1.5 million clients, quite huge. 150K hosts, so there are different services which are deployed on separate hosts. In total, we have these number of hosts where these clients are deployed. This is number of like storage around how many configuration are disturbed. So we have 350 TB. If we talk about like what number of configuration domains, we have 277, and namespaces it's 71,000. Okay, so these are the all details which we have in this architecture. If you are interested in like reading the blog, I will share the like blog link with you in the video description. Go check it out. With For the summary, you can definitely refer this video. We will meet again in the next video with more such discussions, more such engineering architectures which are presented by company or my own deep dives. Till then, stay safe. Tata. Bye bye.